All right, so in this video, we're going to talk about the inventory cost model. This model helps businesses balance the cost of setting up a production and storage. All right, so let's look at an example. So suppose a business wants to produce 400K items in a year. And suppose it takes $1,000 to set up a production run. Once the run of X is produced, once a run of X items is produced, there will be, on average, X over 2 items in storage till the next run. Suppose it costs $2 per item. $2 per item to store items for a year. The question is how long should the runs be? Should the production runs be? Okay, so let me illustrate what I'm talking about with a couple diagrams. Okay, so suppose we do just one run at the beginning of the year. Here's a 1 year mark over here. And so we have 400,000 items, 400K items. And then over the year, the number of items goes down like that because we sell the items over the year. Okay, so let's think about the costs here. So we'll have the cost is going to be the setup cost for the run plus the storage costs. And the setup cost, well, there's only one run, so that'll be $1,000. And then the storage costs, well, at the beginning we're going to be storing a lot, and at the end we're going to be storing nothing. So I claim that on average we're going to be storing X over 2, or in this case 200,000 items. So we'll have 200,000 items on average in our storage facility times the cost per item, which is $2. So $400,000 plus $1,000 is $401,000. Okay, so that's the cost if we just had one run. Okay, so in this scenario, we're spending a lot on storage. And the question is, can we trade off some of our storage costs to setup costs and save some money? So let's suppose we did 100 runs instead of one run. So we'll have run 1, run 2, run 3, ... run 100. If there are 400,000 items and we're doing 100 runs, we're going to have 4,000 items per run. And so after my first run, I'm going to have 4,000 items, and it's going to go down over time to my second run, and then back up to 4,000, down, back up to 4,000, down, continuing on in this sawtooth pattern till we get to the last run, and then down, and this is 1 year. Okay, so each of these runs costs $1,000. So our cost is going to be $1,000 setup cost per run times the number of runs, so times 100, plus the amount in storage that we have. On average, we'll have half of 4,000 in storage, so 2,000. So 2,000 items times $2. And that gives me 100,000 plus 4,000, so 104,000. So you can see we've saved money by trading our storage costs for setup costs. And now the question is, what's the optimal balance between setup costs and storage costs? So let's think about cost as a function, and we'll optimize this function. Okay, so cost is going to be now a function of x. It's going to be the setup costs for runs of length x plus the storage costs for x items. Okay, so we're going to have the number of runs times $1,000 in this situation, plus the number in storage times $2, which if we have x items in our production run, the number in storage on average is going to be x over 2, and the number of runs I claim is going to be 400,000 divided by x. So let's think about this. So we have 400,000 items that we want to build. If we have x is the length of our run, then 400,000 divided by x is the number of runs that we need. We're just dividing our 400,000 by x to figure out how many runs. Okay, so now we have a function. Let's simplify our function a little bit. So c of x equals 400,000 times 1,000, so 400 million, large number, over x, plus x. Okay, so now we can minimize this function using the derivative. Okay, so if we take the derivative, we'll get c prime of x is 400 million times the derivative of 1 over x, which is negative 1 over x squared. And the derivative of x is just 1. And we want to set this equal to 0 to minimize. Okay, so now let's solve for x. We'll get 400 million over x squared equals 1, moving the 400 million to the right-hand side. And then multiplying both sides by x squared, we get x squared equals 400 million, or x equals the square root of 400 million, which is 20,000 items. And if x is 20,000, then the number of runs is going to be 400,000 divided by 20,000. So the number of runs is going to be 20. And our run length is going to be 20,000 items. Let's plug this back into our cost function and see what our minimal cost is going to be. So cost of this 20,000 length runs is going to be 400 million divided by 20,000 plus 20,000, which is 20,000 plus 20,000, which is 40,000. Okay, going back to our initial setup, 40,000 is less than 401,000 and 104,000. So we have found a minimum. All right, I hope you found this video useful.